Hey guys, welcome to another tutorial. Today we're going to be back in UDK. We're going to actually make what I was able to make for something I'm working on the side here. What we're going to make is a trampoline that will bounce K actors and the player, any kind of objects that you want. I know for sure mine does K actors and players. I don't think it will do interp actors, but who knows. But let me show you what I got. So we have this pad right here. This right here is the trampoline. You jump on it, you'll continue to bounce higher and higher. And then on the log, we have the player's Z velocity as they're bouncing up, so we know that's getting higher, so you bounce higher. And right now it has a cap of about, I believe, 1500. The reason why I stopped bouncing there is just because it's low to the ground. So my collision touched this floor instead of that floor, but if we do just a normal object, this one will bounce to its maximum. And I'm using this as a form for it's a method in one of my puzzles here. Just a method I want to get for a puzzle I'm designing, just so it can bounce and you can grab things and have it kind of scale vertically, so you don't have to bring it up to certain sections and things like that. So that's overall going to be what we're going to work on today, this trampoline that I have down there. So let me go ahead and break it down, show you how we do it. So the first thing we do, we set it up so that the player has a physics gun at the beginning, just so he can spawn with it and nothing else. And this is the main logic. It's actually pretty short in terms of what it is that needs to be done. So overall, our main event is the touch from this trigger volume between any object that it wants at that point. What we do is as soon as the object touches it, we get its velocity, and then we break down its velocity into its vector components, so x, y, and z. Obviously, if we're doing bouncing vertically, just normal, that's your z-axis. So what we do is, when we get the vector components, we focus on the z velocity, and what I do is I multiply its velocity when it touches this. We multiply it by -1 because when it's touching the volume, at that point its velocity is negative, so when we want it to bounce back, we multiply it by -1 so that the velocity is positive again, so it goes up positive. And just so it can get how it can bounce higher and higher each time, what we do at that point is we add 100 to the value after it's multiplied by -1. So say its velocity is -100 when it hits, we multiply that by -1, so back to 100, but then we add another 100 so it bounces just a little bit higher. And at that point, what we do is we compare that value. Obviously this is only if you want a cap. If you take this check out, the box or whatever it is will bounce higher and higher forever until you tell it to basically stop at that point. But I wanted to have a cap on it just so I can have it controlled a bit, and I have it at 1500. So whenever the velocity is less than 1500, we keep setting it like normal. We keep increasing it each time. But once that value, the player's velocity becomes higher than 1500 or equal to 1500 or anything like that, that's when we set it to 1500, so it'll stop at that. And then once all that's set, we then set the vector components again. So we have the box's velocity, we have the x, y, and z. And then lastly, we set it again. So we set the velocity of whatever it is that's touching it back to whatever it was initially. So that's how we do it. So now let's go ahead and just get rid of everything, start from scratch. I'm not going to redo my environment, I'll just explain what the environment's made out of. So, sorry about that. So what we do in terms of setting up the scene, we have a static mesh, which is the red box here. It's just to kind of make it look different so you know it's the trampoline at that point. But then we have a trigger volume. So if you don't know how to make a trigger volume, you just go to your brush, whatever shape that may be, and then go under volumes, and then down here to trigger volume, and you'll get a trigger volume that we need. And then we also have our K actor. One important thing to note about the K actor is in its value properties. If you type in encroach, you'll notice mine is unchecked. We want to make sure it is unchecked because that's how it recognizes touch events with trigger volumes or just normal triggers, things like that. If you didn't have that unchecked, you would not get any kind of reaction for when this touches this volume. It's one of the most important things that I've learned overall while working with K-actors to do some scripting and puzzle design in Kismet is just make sure no encroach check is checked off. So that was a medium mouthful, but overall that's the setting of our scene, the most important aspects. But then I have this platform that allows me to climb all the way up. So you can set it up to whatever you want to be in terms of your environment, but that's just for me to get it going. One last thing is under View, World Properties, our default game type, it's UT game. And I also check no default inventory for players, so as soon as you spawn without any kind of Kismet scripting, you get no weapons. You just get a blank so we can't fire anything. And we know this isn't working or anything like that. And we can't also pick up this gun, or not the gun, but this crate because we have no physics gun. So that'll be the first thing we do. It's really easy to set that up. When we want to have it, we want to have a player spawned event. Whenever the player spawns, we give them the physics gun. So the fastest way to do that is to go under miscellaneous, console command, plug up those two up to each other. And then under target, hold down the P key and left click to get all players. Now we're going to uncheck all players just so it's player 0. I also select my spawn point, where I click on spawn point and set that as the variable. And that's all you really need. So now when I spawn in, actually, derp, no it's not, actually, in the console command, you actually have a console command. So to get the physics gun, the actual console command is physics gun, no spaces or anything like that. So now if I spawn, I'll have the physics gun. And we did it. Yay! So we could just throw this anywhere we want. And now we get that working. So now for the meat and potatoes, what we're going to do initially is we're going to make 2 variables. One's going to be a blank object variable to hold whoever touches that volume. And the other, actually there's 2 others we're making here. We're making just a z velocity float variable, and then we're also making a velocity vector variable for whatever touches the trampoline. So let's make the variables first. Let's go ahead and make the object one. So we'll go under new variable, object, and then object. We're just going to name this instigator. To whoever touches the volume, it gets placed into that empty object variable. Next, we're going to make a vector variable. So let's go under new variable, vector. This is going to store the x, y, and z values of our velocity when we touch the trigger volume. So I'm just going to name this instigator velocity. And then we're just going to make one float variable for right now. It's going to be for z velocity. So let's go under float and then float. I'm going to name this instigator z velocity. We'll leave it at 0. So that's all the variables we need right now. So let's get this going. So the first thing we need to do, let's get our trigger volume. Then let's right click in Kismet. Let's do new event using trigger volume 0. It's going to be touched. So now let's expand this whole thing now that we have more room. So the first things we're going to do here, under touch types, we're going to take off pawn and just add it so it's just none. So you can just go under pawn and then go under N for none. Or you can X out the whole thing, create a new one, and it just defaults to none. That's usually what I do because it's faster. We're going to uncheck force overlapping because that's basically forcing the player to overlap with the trigger volume at activation. We don't want that to always happen. And then max trigger count, honestly we want this to happen an infinite amount of times. And then let's uncheck player only because we obviously want it to be more than just the player. So now we have it set up so K-actors can react to it, interactors can react to it, the player can interact with it, almost anybody can really interact with it. So that's all we need so far. But let's right click, let's do a new variable, let's do a new named variable. We're going to do the object variable, which is instigator. Got the check mark, we're going to put that under instigator. So the very first thing we want to do is get the velocity of the object as soon as it touches the trigger volume. So let's go under new action, actor, get velocity, plug that right in, then target will be instigator, and then its velocity vector. Let's make a new named variable, so let's copy and paste this one, change its type to vector, and rename it to instigator velocity, and then plug that right up. So now that we have its velocity, obviously we want to break it down to each vector component, x, y, and z, so we can control each one independently. So what we're going to do, under new action, I believe it's under math, and we're going to go get vector components. So we're plugging that in, and it basically asks us, hey, you know, what vector do you want to get the components of? We want to get the instigator velocities vector, and then all we really want for right now is the z. So let's make a new name variable, change its type to float, change its name to instigator z velocity, plug that up to z, and then as soon as we actually have that vector component, that z, that's when we want to go ahead and do the math on it, where we're going to basically negate whatever value it is by multiplying by -1, and then adding an additional value to it. So let's go to new action, math. Let's do multiply float. So A is going to be the z velocity that we grab here, and that's also going to be our result. We want whatever the result would be to go back into this variable. And then under B, to create a new float variable, just change its value to -1. Now that we have it positive again, we're going to go ahead and add an additional value, because if we left it as is, it would just keep bouncing the same height. It won't increase the height as it's bouncing. So let's go to new action, math, add float. And then again, we're going to grab the z velocity, making that A and the result. And then for B, let's make this 200. You know, this could be any value that you want, whatever one works best for you. So I'm just going to make that 200. So now that we did the math, before we actually put a condition in, let's just have it so we set it up where it infinitely bounces. Let's say we don't have that check yet. So what we'll do here, we'll do new action, actor. No, actually it's under math. We're going to set vector components again. Let's grab instigator velocity. That's going to be the output vector. And then for z, we have the instigator z velocity. Going to throw that on. And then we're going to go to new action, actor, set velocity. So our target, again, it's going to be our instigator. And then the velocity direction, that's going to be instigator velocity. So that's all you really need. So let's see if it's working. Let's see if we have an infinitely bouncing box here. So far it's working. And it won't have any kind of max. So it'll just keep bouncing. Until you tell it to stop. Let's see if I can grab it. Oops. So we know that's working. Let's see if the player's working. Yep. So we're bouncing. And the reason why I stopped is because the collision for this box right here that's underneath, it's too close to this object. So this object would, if anything, need to be thicker for me to continue doing that, but we don't really care at that point. So one thing, if you notice what we have it set up with so far, is no matter how I throw it on, so say I give it like a kind of like a forward throw, it kind of just stops and then starts bouncing wherever it lands. So that's one way to go about it. That's something I like. It looks cool when it does that, but for a more realistic bounce where it would actually kind of skip across, we need to set something additional up. So let's go ahead and set that up. What it entails is actually getting the velocities for x and y as well as z. So what we're going to do, we're going to copy and paste these float variables, change them from z to y, and then y to x, just so we have all three. And since we're only increasing the z, we don't have to do any math on those two other vectors, or yeah, vector components. So what we need to do really is just hook these guys up, set these guys up here so they can get their values. Since we're not changing their values, it doesn't really matter what they are. But now that we have them hooked up, and then what we need to do is then hook them up as well at the end, or setting the vector components. As long as we do that, when we play now, when you throw like a little skip across, it'll actually bounce across like that. And it does it for both sides. So now we have it kind of skipping across the trampoline surface. Same thing goes for the player. Now so we know that we have that working. The only thing now we have to do is, say you want to have a cap on it. You don't want it to be infinitely bouncing. Say you actually have a ceiling on the roof or something. Not the ceiling on the roof, but a ceiling in the room. Or you just want to have a cap on it overall. I'll show you how to set that up as well. We need to break it from where we add the final float value to the z, and then when we start setting the vector components, we need to break it there. And that's where we need the condition. So let's go to new condition, compare float. Basically, we say you don't want the z velocity to get any higher than 2,000, for example. Let's go ahead and set up the z velocity for A, and then for B, we're creating a new float. Let's make it 2,000. So if A is less than 2,000, we want to set everything like normal, and we also want to do that when A is less than B as well. So as long as A is less than B or A is less than or equal to B, we're going to set it like normal, like we're going to keep adding it and adding it. But as soon as it hits 2,000, that's when we actually just want to set this variable to a stationary value. So we're going to go to new action, set variable, float, we set z velocity, which is our target, and then the value is going to be 2,000. And that's going to happen whenever A is equal to B, A is greater than B, or A is greater than or equal to B. And then from there, we're going to set the vector components. With that set up, let's actually get a log going so we can see the value. So let's hold down L to get log. Holding down the P key on target, you get all players. Let's uncheck all players so it's just us. And then right click, let's expose the float variable. And let's put the instigator for the z velocity on there. So now we'll log the actual z velocity of the object as it's bouncing each time it bounces. So let's see if we can get past 2,000 or if our logic is correct at this point. Oops. Lost it. So let's start it all the way up here. So let's drop it. So it's at 1,200 right now, 1,400, 1,600. See, it's getting closer and closer to 2,000. So now it should cap. It's pretty close to 2,000. So now it's at 2,000. Let's see if it goes any higher. Nope. So we got that working. So now we have it so you guys learned how to set it up initially to have it bounce as high as it wants. Now you know how to put a cap on it. And then you guys also learned how to make sure you kept the directional velocities of all three as it's bouncing, if that's what you want to have it set up as. So overall, that's it. That's all it really takes to get that set up. With that, that's probably going to end it for this tutorial. I do want to thank you guys for watching, and I just want to talk about, I have been a little, I wouldn't say quiet, but inactive recently, but that's because I'm actually working on something really important. This tutorial is actually from me working on what it is I am working on the side here. I'm actually not working on the side, I'm working on it full-time at this point. Hopefully I'll get to tell you guys about it soon, something I can't talk about right now. But hopefully I have some news for you within the next month or two to share with you guys about the thing I'm working on. But until then, I'm going to do my best to be as active on here as I can be. I should have more free time to work on this within the next week or 2 weeks from now. So keep an eye on that. And we'll have more tutorials. And I do, again, thank you guys for watching. I appreciate your support. So if you haven't already, subscribe, like the video, share it with your friends. Also comment with suggestions or any issues you may run into. I'll try my best to help out. But until then, I'll see you guys next time. Thanks for watching again. Bye-bye.